This channel aims to provide you with new perspectives through our videos. In this particular video, we'll be covering the theory of everything in just 15 minutes.
Can the theory of everything be understood in just 15 minutes?
I'm fully aware that it's a bit ambitious, but I'll do my best to explain it. Let's get started. The universe is a steady-state universe.
Excuse me, isn't the universe an expanding one?
I'm not accepting any such comments this time. I'm not going to compare this with conventional physics. If you're wondering why, please watch another video on this channel.
So, you're telling me to forget common sense, clear my mind, and just listen, right?
Exactly. Let's continue. This universe is a steady-state universe where a single space exists, and many particles are flying around in it.
Just particles? There are also substances like atoms, right?
Don't rush. Space and particles have a mutual relationship.
A mutual relationship?
Space gives particles velocity, and particles give space energy. This relationship is what the theory of everything is about.
We've suddenly arrived at the conclusion.
Of course, this video is meant to explain how the universe is created based on this theory.
I see. So everything we see and touch is based on this theory.
Exactly. This simple rule is everything, don't forget it.
But setting energy aside, what exactly is velocity?
It's the information needed for particles or atoms to move through space, like a pass. Of course, it also directly represents the speed at which they move.
So, without the information of velocity, they can't move through space? It really is like a pass.
Well, think of it as a way to help you understand. In reality, we don't know what velocity truly is, just like how energy can't be defined in physics. Anyway, what's important here is that it's information.
I understand. So photons emitted from a flashlight don't reach 300,000 kilometers per second because of electrical force, but because they receive the information of 300,000 kilometers per second from space, which accelerates them to the speed of light.
I'm glad you understand quickly. That's why changes in voltage don't affect the speed of light.
I understand how space gives particles velocity, but how do particles give space energy?
While physics can't define energy, the theory of everything can define it clearly. When particles move through space with the velocity given to them, they slightly contract the space in the direction they are moving. When multiple particles intertwine, they start to wind up the surrounding space as they rotate.
Winding up space?
Space doesn't have fluidity, so winding up is just a simplified way of explaining it. Space contracts towards the center of rotation, and when it contracts to a certain extent, it becomes a proton and separates from space. By the way, protons rotate because particles are continuously given speed by space.
Protons originally come from space?
Yes, that's right. I told you, this universe consists only of space and particles. The rotating proton continues to contract space, and when it contracts to a certain extent, it stops rotating, transforming into an atomic nucleus. It then involves the surrounding space, further separating from space and growing into an atom. This balance between the pulling forces of space and the atomic nucleus is what defines an atom.
So atoms are also made of space?
Yes, atoms that have separated from space go through this process to gain energy in the atomic nucleus.
Energy refers to the contracted space?
Exactly. As the number of protons in the atomic nucleus increases, the amount of contraction increases, including neutrons. This gives rise to the concept of spatial density.
Spatial density?
If space contracts, density increases, and if it expands, density decreases. It's very simple, right? Since it's density, this can be quantified.
So, even atomic nuclei can be quantified in terms of spatial density?
Yes, and that's what we call mass. And this mass changes.
Well, that makes sense because the mass of hydrogen is different from that of oxygen.
No, I mean the mass of hydrogen itself changes.
When you say the mass of hydrogen changes, you mean the spatial density of the atomic nucleus changes, right?
As I mentioned earlier, the atomic nucleus and space are pulling on each other. It's influenced by the spatial density outside the atom, like this.
So atoms have such a function.
This is proven by the equation E equals mc squared, but the details are in a separate video. And what happens on a microscopic scale also happens on a macroscopic scale. In other words, celestial bodies like the Sun and Earth are just like protons, and by rotating, they contract space in their central parts. However, unlike protons, celestial bodies are dominant in their tug-of-war with space, so they continue to rotate. As a result, the spatial density gradually increases as you get closer to the center. Einstein referred to this as the warping of space.
I imagined the warping of space as being pushed outward by celestial bodies.
It's the opposite. Imagine it being pulled inward toward the center. Doesn't a swirling galaxy look as though it's winding up space?
Indeed, it does.
This density difference from the center of the celestial body creates a force field in space, and matter moves from areas of low spatial density to areas of high density. This is gravity.
So, we're not being pulled by the Earth, we're actually moving toward the center of the Earth.
Exactly. There's no such thing as universal gravitation. However, gravity isn't established solely by this force field.
What do you mean?
To explain that, you need to know one more rule of the theory of everything.
Another rule?
Particles can also return the speed they are given to the space.
Wait a minute, is it speed and not velocity?
Yes, here we only care about speed, the direction doesn't matter.
Then, how is that speed being returned?
Are you familiar with the constancy of the speed of light?
The constancy of the speed of light? That's common knowledge in physics.
The observation of a star behind the sun during the 1919 solar eclipse proved that the speed of light is not constant.
But that proved that light travels along warp space.
That's completely wrong. Do you know about Fermat's principle, which states that light takes the path that requires the shortest time?
Of course, you're talking about the refraction of light, right?
As a result of taking the shortest time path, starlight curves around the sun and reaches the Earth.
So, this means that a curved path is faster than a straight one, right?
Yes, therefore, this observation indicates that light slows down as it gets closer to the center of the sun. In other words, the speed of light is not constant.
That makes sense.
But why does light slow down as it gets closer to the center of the sun? It's due to the density of space. As the density increases, it becomes more difficult for light to travel through. This is quite obvious if you think about it.
But what about the Michelson-Morley experiment that proved the constancy of the speed of light?
I've explained that separately, so I won't cover it in this video. So, if the speed of light changes, it means that photons are interacting with space and speed.
I see, so when photons slow down, they are returning speed to space.
Exactly. Additionally, when discussing light, light is a particle, not a wave.
What are you talking about?
When photons slightly contract the space in their direction of travel, and when this happens on a large scale, it creates large periodic waves due to a resonance phenomenon. These waves are waves of spatial density differences. As photons move through these waves, they repeatedly accelerate and decelerate, returning the given velocity back to the space each time. The velocity returned to the space causes the electromagnetic field present there to oscillate, allowing us to observe light as a wave. So, we can say that the wave is a difference in spatial density.
A difference in spatial density?
I think this explains how particles return speed to space. Following this rule, gravity causes particles to leave speed behind within matter as they pass through it. This residual speed accelerates the matter in the direction created by the force field.
I see. Since the spatial density within an atom decreases, particles accelerate, but when they exit the atom, they leave behind the excess speed inside the atom.
Exactly. Matter is moved by these two elements, force fields and particles.
Could it be that magnetism and electricity work the same way?
They likely share the commonality of moving matter through force fields and particles. Now, I'll explain nuclear fusion and nuclear fission. Celestial bodies create force fields due to the differences in spatial density that occur when space is contracted. Conversely, when space is released, a force field can also be created through differences in spatial density. This is exactly what happens in nuclear fusion and fission, where the contracted space within the atomic nucleus is released to create a force field.
So, nuclear fusion and fission are the opposites of gravity.
That's right. By the way, supernova explosions work on the same principle, where celestial bodies release the space they had contracted. Furthermore, even the energy created by covalent bonds between atoms follows the same principle.
Could the expansion and contraction of space explain the four fundamental forces of nature?
I think I've managed to explain gravity and the strong force, but I'm not so sure about electromagnetism.
So, what about the weak force?
It's the same with the weak force. When an electron is emitted from a neutron, the space that the electron was contracting simply moves along with it.
In other words, the three can be explained through the stretching and contracting of space.
As for electromagnetic force, it's still not sufficient unless we fully understand electrons. Now, let's move on to explaining the equation that unifies Newtonian mechanics, relativity, and quantum mechanics.
Is such a thing even possible?
It's enough if you consider it might be possible.
I see, understood.
The new mechanics considers things not at the level of mass points, but at the atomic level. It's called interatomic mechanics.
Interatomic mechanics?
Yes, the motion of all atoms in the universe can be expressed using this formula.
With just two equations?
Yes, just two. However, there's a condition. It only applies to the motion of a single atom.
Doesn't that make it somewhat meaningless?
No, it doesn't, because matter is a collection of atoms. Anyway, let me explain the equations. Atoms carry not only speed, but also information about their direction of movement. This information, based on input, allows them to move in any direction, up, down, left, or right, like a compass. And the atom ultimately moves in the direction where it stops.
It's like an arrow.
When that arrow moves, the atom loses speed. In other words, it slows down when it turns. Let me give you an example. A single atom is currently moving through space with a speed of 2. From 90 degrees to the right of its direction of motion, a speed of 2 is applied. As a result, the atom's speed increases to 3, and its direction of motion tilts by 45 degrees.
So, by adding the initial speed to the added speed and subtracting the speed lost due to the change in direction, you get 3, right?
Exactly. So if the direction changes by 180 degrees, all speed is lost. Also, in the case of gravity, since the input speed is sustained, it is necessary to introduce time variation in order to formulate it.
I see. But it seems like mass isn't included in the equation.
That's the crucial point of this equation. Even though it's a mechanics equation, mass isn't involved.
What do you mean?
You know that the speed of a falling object due to gravity is the same regardless of its mass, right?
That's the principle Galileo discovered.
That's your answer.
What do you mean?
Gravity accelerates each atom simultaneously because it's caused by a large number of particles passing through the material. The fact that the fall speed is the same means that there's no difference in motion at the atomic level.
So, if the same information is input, any atom will behave the same way.
Exactly, and that's what's happening in reality, isn't it?
What about when there are 2 or more atoms, or in cases other than gravity?
Information is always moving within the material, and as the atomic mass increases, or as the number of atoms increases, the information transmission between atoms slows down.
What do you mean by a delay in information transmission?
I suspect that the speed of information itself doesn't depend on the atomic mass or the number of atoms, so that's still just a guess. Moving an object means equalizing the information of its atoms. If there's even one piece of different information, the object won't move. So, a delay in information transmission could be thought of as a delay in the equalization of information.
I see.
And this delay in information transmission is what physics refers to as inertial mass. As for weight, it's heavily influenced by the reaction force, so let me explain it again using an equation. Assuming that the reaction force on S1 is at rest, the equation would look like this.
A formula that can even calculate the reaction force. What a convenient equation.
For example, if the wall is S1 and the ball is S2, the speed of S2 would be reflected back to the ball due to the reaction force from the wall, causing the ball to fly in the opposite direction.
So, the reaction force returns the speed information directly.
Exactly. And this is the same for gravity. Weight is generated through this process. As I've mentioned before, in gravity, each atom in your body receives speed information, which propagates from your entire body down to your feet, where it's transmitted to the ground and then returns as a reaction force. This process happens continuously.
But wouldn't the gravity and the reaction force cancel each other out, making the net effect zero so that weight doesn't actually exist?
No, that's not the case. Information isn't transmitted instantly, so a time lag occurs before they cancel each other out. The slower the information transmission, the greater this time lag becomes. And that's what we perceive as weight.
So, both weight and inertial mass are caused by the delay in information transmission.
In reality, gravity and opposing forces intermingle, creating a chaotic state within matter, so simplifying it is very difficult.
The simplest thing to measure, weight, is actually the hardest to understand.
This concludes my explanation of the theory of everything, but did you find it satisfactory?
Yes, it was very informative.
Good. But since we have some time left, I'll also teach you about centrifugal force, or more precisely, the force you think of as centrifugal force.
Yes, please do.
Centrifugal force is essentially a delay in information transmission, meaning a delay in information equalization. For example, the centrifugal force you feel when riding in a car is caused by a delay in information transmission, resulting from a mismatch between the information of the car and the person.
I see, so is acceleration g the same phenomenon?
Exactly. Information isn't transmitted instantaneously, and physically speaking, force isn't transmitted instantaneously either. And just like that, theories that defy common sense don't spread easily to the public.
That's not exactly a cheerful thought to end on.
That's the point. For those who want to learn more about the theory of everything, please check out the videos on this channel. The content might differ slightly, but this video contains the most updated information. Lastly, don't forget to subscribe to the channel and give it a thumbs up.